The next topic that'll impact you is collections of objects. A collection is simply an object that knows how to manage references to multiple instances of other classes. So it keeps track of other objects. There are probably a dozen different collections to choose from, each with their own distinct superpowers. Some are created to keep objects sorted, and some are created to allow for easy retrieval. Collections are used all over the place in the .NET Framework class library, and we'll even be using them ourselves when writing our own applications. For example, on day 4, I'm going to demonstrate how to build a note-taking application that stores GPS information where the note was originally created. And so each note object will be stored in a list, which is one of many possible collections we could choose from, a list collection. So for now, I'm only going to focus on the list collection because it's the most simple one, in my opinion, and it's the one that we'll use mostly throughout this series of lessons. Alright, so as you can see in Visual Studio, I have a project open by the name of Collections. I've already taken the liberty of adding a few controls. For example, this Just Do It button named My Button. I also have a text block named My Text Block. You can see here that I've formatted it so it's a little bit larger, takes up a little bit larger area, and I've turned text wrapping property to wrap. I'm going to double click the Just Do It button, and we can see we now have our event handler. So the first thing that I want to do is create a class that we can work with. I'll just recreate the car class from earlier in today's lessons. We can define a class like we did in the previous lesson inside the main page.xaml.cs. However, most developers prefer to create a new file for each new class, or at least create a file for each set of related classes at the very least. This technique helps developers find what they're looking for more easily by navigating the Solution Explorer instead of having to hunt through many different files or many lines in a single file to find what they are looking for. Regardless of where you put the code, it gets compiled all the same, so that doesn't really matter. But let's go up here to our Add New Item. I'm going to click the little down arrow to the right-hand side of the icon and select Add Class. I'm going to make sure that Class is selected in this main area of the Add New Item dialog, and I'm going to change from class1.cs. I'm going to call this car.cs and click the Add button. And then I'm going to use that prop technique I demonstrated earlier to create two properties. We'll keep it really simple for this example. So prop tab tab, string tab tab, make, enter enter. Prop tab tab, string tab tab, model, enter enter. So now I have two public properties, make and model, for my car. I'm going to go back to the main page.xaml.cs file. Inside of the my button underscore click, I'm going to paste in some code that I've already written because there's actually quite a bit and I don't want to take the time to type it all out. In this snippet of code that I've pasted in, I created 3 instances of the car class. The first instance is called car1, the second instance car2, the third instance car3. Each of those I've set properties, make and model to various values. An Oldsmobile Cutlass Supreme, a Geo Prism, and a Nissan Altima. Next, what I want to do is add each of these instances of the car class to a new collection, a new list. And once I have them in the list, then I want to loop through each item in the list using a for each statement. I'll explain that in just a moment. And I'm going to inspect the properties of each instance of the car class, adding it to a string that I'll then display on the text block on the phone's user interface. So I'm going to write some code and then I'll come back and explain each line. Alright, let me run the application to make sure it works before I start commenting on it. Alright, it seems to do what I intended for it to do. Okay, so now that I know that it works, let me take a few moments to explain the code that I wrote. We already talked about this briefly. Here we're creating 3 instances of the car class, and we're populating its properties with just random data. Next, I'm creating a new instance of a collection, a list collection, and you can see that I'm using the new keyword to create a new instance of that class, the list class. Now, this is not just any kind of list. This is a list that can only work with the data type car. You can see that I've defined it here using the angle brackets and the word car in between. So this is a list of type car, and this is creating a new list of type car. So note that the type of list that I've used here, it is a generic list. This could lead to a larger discussion on the topic of generics, but that's really outside the scope of this series. Just memorize this basic syntax for creating a list that can contain only a specific type, and in this case that type would be a car class, and you're going to do pretty well for yourself as you work through .NET. Next, the list object has a number of methods for managing the objects that it holds a reference to. The add method, as we see here in lines 39 through 41, allow us to add a reference to the list. So we are merely adding references to each of the cars which we pass in as input parameters to our list. Now our myList holds a reference to each of our 3 instances of the car class. Here I've defined a string called myCars, which I'm going to use to start building a string that will display ultimately in our text block on line 49. But what's after that declaration in lines 44 through 47 is a for each statement. Before, we've used the for loop, and this is similar in how it works. It's just different in how it loops through each of the items. Before, we used some sort of an iterator. We incremented the iterator and so on. The for each works with collections. It'll say for each item in my list, iterate through this block of code that's defined below it. So in this case, for each class of type car, and I'm going to call it car with a lower c as opposed to car with a capital C. So the .NET Framework understands that we're talking about the class here, and we're talking about just a variable here called car with the lowercase c. So each car in my list, the list that we've added cars to, loop through that many times in the code block below it. Each time you loop through, add the make and the model of the current car, and then add a new line. Now you might be asking yourself, why were we able to leave off the word system? Didn't we use system.environment.newline? Well, remember our discussion previously about namespaces. If you take a look at the very top of this file, you can see that there is a using system namespace, so we don't have to type in the entire name. The same thing is true for the list itself. Here I'm just using the keyword list, but the fact of the matter, if you hover your mouse cursor over it, you can see that it is a class of type system.collections.generic.list. And so we would expect then to see a using statement here, system.collections.generic. Okay, just wanted to point that out to make sure that that's obvious to you as you work through this example. So to recap, a collection, like a list, manages a reference to one or more instances of a class. Once we have a single object that manages several objects, like instances of the car class, as we demonstrated right here, then we can iterate through them using the for each syntax like we did in line number 44. You work with collections of objects often in the .NET Framework class library. In the next lesson, I'm going to show you a shortcut that some developers use, and you can see examples online and on MSDN of how to create instances of objects and collections and initialize them all in one step. It's related to what we're working on here, so we're going to keep this same project open for the next lesson. We'll see you there. Thank you.